Today we're going to be looking at Unit 2, Lesson 9, or the second half of Unit 2. Now the second half is all going to be dealing with this idea of parallel lines and something called a transversal, which we'll get to what a transversal is in a moment. So as a reminder, in Unit 1, we talked about what a parallel line is, or line segments. We talked about what perpendicular lines or line segments are. We also talked about what skew are. So let's refresh real quick. First, parallel lines. Parallel lines are two lines that do not intersect and are on the same plane. All that a plane is a flat surface. So the major thing that you need to remember is two lines that do not intersect and they go the same direction. We denote or show on the picture parallel because of those two lines. Those two lines tell us that it is parallel. They're moving in the same direction. So we can also write the notation for this. We can say AB is a line, so I have the arrows. The two vertical bars, remember, mean parallel. So AB is parallel to CD. Perpendicular. Perpendicular are two lines that are on the same plane and create a right angle. It is very important to remember the definition of perpendicular means that they make a right angle. So to denote it on the picture, we have two lines or line segments, and we have a right angle. Remember that box means right angle. So let's talk about the notation for perpendicular. So we can say line EF. And the symbol for perpendicular is the upside down capital T. So line EF is perpendicular to line GH. Last but not least, there is skew. Skew is two lines that will never intersect and are on different planes. In other words, there are two lines that will cross and they're going different directions. That is the key thing for skew. Now, there is no particular notation for skew. Just know that they're going in different directions. They will not cross. So let's look at our first example. First example. Assume all corners are right angles. Now the first column says segment TS. I know it's a segment because it has just a bar. So segment TS is parallel to what? So I'm going to mark segment TS on our diagram so we can use that as a reference. So we're going to be looking for the first column, things that are parallel, things that are going in the same direction. So for example, QR would be parallel. They're moving the same direction. They also will never cross. Not only does QR never do that, but PN or NP does not matter the way you write these. So segment PN, take a moment and see if you can find the third segment that would be parallel. The third segment, actually segment LM. They are moving in the same direction and it will never cross. second column, or the middle column, is the upside down capital T. So that is our perpendicular. So we're going to be looking for segments that make a right angle, or they intersect. So, for example, SR would be one. Notice on how they both share point S. So segment SR would be one. Not only segment SR, but segment TQ as well. And if we look, we can also go down the side. So segment TP would be one. As well as segment SN. So let's look at this last one, skew. So remember, skew means that they go in different directions and will not cross. For example, if we talk back about that segment SN that we had, instead, see how they cross at point S? Well, instead, if we're talking about segment RM, those will not cross them. So RM would be a segment. They're moving different directions. ST is moving left to right. RM is moving up and down. See if you can find another one moving up and down. Segment QL is our other segment moving up and down. That would be skewed to TS. Well, we technically have two more. So if we call TS is moving left to right, side to side, QL and RM are moving up and down, this is a three-dimensional image, so we could be moving front to back or back to front. So PL would be one. As well as NM. This example we have dealt with before. This example is one intersection. So because we have one intersection, we could have vertical angles or we could have linear pair. This is what we've talked about up until this point. Well, according to this problem, we want to find the measure of angles A, B, C, and D. Looking at it, I see angle B and D have X in it, so I can use those two. I also notice that B and D are across from each other, so B and D are vertical angles. So I know angle D and angle B have to be congruent because they're vertical angles. I know that angle C and angle D, or C and A, have to be congruent because they are vertical angles. For this unit, you will notice we will be doing a lot of highlighting. I would recommend having a highlighter and highlighting along with us. So, same color means they are equal. They're vertical angles. So I can say 9x plus 1 equals 2x plus 36. I'll draw my line if that helps. Now we're going to solve for x. So we do have an x on both sides. So I'm going to get rid of the smaller one. Subtract 2x from both sides. So I have 7x plus 1 equals 36. I'll subtract 1 from both sides. So 7x equals 35. Last but not least, I will divide both sides by 7. To get x equals 5. We had to find out what x is in order to find out angle measures. So the only two that we can deal with right now are angle B and D. So I will deal with angle B. The measure of angle B equals 9 times our x, or 9 times the 5, plus 1. Measure of angle B. Well, 9 times 5 is 45, plus 1 is 46. So I know the measure of angle B is 46. We can also work smarter, not harder, because we set angle B congruent or equal to angle D. I know the value of the measure of angle D as well. Measure of angle D has to be 46 as well. So then the question becomes, how do we find measure of angle A or C? Well, angle A and B form a linear pair. Remember, linear pair means supplementary. So I know the measure of angle A plus the measure of angle B, which in this case is the 46, equals 180. I'll subtract 46 from both sides. So by taking 180 minus 46, we end up getting 134. Now, just like what we did for angle B and angle D, how they were across from each other, so they're vertical angles, so they're congruent. Same thing is true with angle A and angle C. They are across from each other, so they too also have to be congruent. I know measure of angle C, also 134. So, the two angle pair relationships that we talked about, vertical angles and linear pair, you will always have, because those happen when two lines cross. However, if we added another line, such as seen on the screen now, we have more relationships that could happen. Now, a line that cuts across two or more lines is called a transversal. So this diagonal line that you see is a transversal. Now, the relationships that are shown when we have parallel lines or just two lines and a transversal. First one is called alternate interior angles. Now, the word alternate means opposite sides. And by opposite sides, we're referring to our transversal. So we want opposite sides of that transversal. And then interior, just like the interior of a house is the inside, we're going to view our two lines as a house. So it's in between those two lines. So for example, angle C and angle F would be alternate interior angles. They're on opposite sides of that transversal, and they're both inside of the parallel or inside of the two lines. Another pair would be angle D and angle E. Those would be our alternate interior angles. Alternate exterior angles are just like the interior, except now we're talking about outside of the parallel lines, or outside of our pair of lines. So we could say angle A and angle H are alternate exterior angles. We could also say then angle B and angle G are alternate exterior angles. The other two relationships, one is called consecutive interior, which we may also refer to same side interior. Now, what consecutive interior or same side interior is referring to, well, consecutive is next to each other, or same, you can think of it as the same side. So we're referring to the same side of our transversal. Let's get interior, so inside. So this would be angle C and angle E would be a pair. Well, angle D and angle F. Those would be our our same side interior angles. Corresponding angles is our fourth and final type of relationship. Corresponding match with each other. We can think of it as same spot in our intersection, but in the other intersection. By that, I mean if we look at the A is in the top left of that intersection, so what matches with it below? Well, angle E. They're both in top left of that intersection. We could also say angle B. Angle B is in the top right of the intersection. That one matches with angle F. Angle G is in the bottom left. That matches with angle C. The angle D matches with angle H. So when we have two lines in a transversal or a line crossing them, these four relationships come into play.